Right, so back again, let us just state what it is we're trying to do. We are going to determine an equation to describe the bending moment between C and D and confirm the location and magnitude of the max moment. Okay, so as you know at this point, we want to make a cut at a distance x from the left-hand support where that cut comes down between C and D. Okay, so we can sketch it out first of all. Okay, let's take the sum of the moments about the cut. Alright, and simplifying all that down, we get our polynomial to describe the moment, the internal moment, in that region, and it's equal to minus 10x squared plus 156.3x minus 187.5. Okay, so that's the equation we were looking for that describes that bending moment in that region. So it describes the curve of our bending moment diagram in the region. And again, let's just confirm that that is for x values greater than or equal to 5 and less than or equal to 10. And now what we want to do is differentiate that to get the slope. So the differential of that expression, dm dx, is going to be minus 20 times x plus 156.3. Now we're going to let that slope equal to 0 and solve for x. So what do we end up with there? We end up with minus 20x is equal to minus 156.3, and so x is equal to 7.82 meters, i.e. 2.82 meters to the right of C, which is exactly what we got in the previous video. So let's just say i.e. 2.82 meters to the right of C, and we know that's correct. Okay, and now what we have to do is sub in this value for x back into this equation up here to get the value of the moment at that location. So m for x equal to 7.82, and what would we have? Okay, and that would all equal to 423.24, which is approximately equal to the 423.4 I got previously, and the difference there is just down to rounding differences. So practically speaking, we've done exactly what we set out to do. We've worked out, or we've confirmed, the location of the maximum bending moment, and we've confirmed the magnitude of the bending moment at that location. Okay, right, so that wraps up that example.